So maximum path sum, which all you know, that I hope you all read the question problem statement clearly. For simplicity, now let us understand the problem statement once again. So it is stating that a path of binary tree is a sequence. First they are trying to explain what is meant by path, because the question is about maximum path sum. So we need to understand. So first of all, we need to understand that they are giving that each pair of adjacent nodes has a adjacent connecting node, that is known as path, that already know. Okay, node can appear at least only once. This is important point. Okay, the root of the binary tree return the maximum path sum of a non-empty path. Okay, so let us understand the examples first. So if you see clearly over here, so this is the first test case that you can see over here. So this is one of the path. Okay, this is one of the path, this is one of the path, and this is one of the path. So you can see there are so many possibilities of the path. So that's why we use the recursion topic. So if you want to traverse any of the trees or that kind of stuff, so you can definitely think of the recursion, because we have so many possibilities. You can also try with the that is the loops or iterative approach also, but in trees and graphs, the recursion is the best way to do it. Okay, now we understood what is meant by path. So if you observe the elements in the path, which is 2, 1, 3, if you add all of them, you will get 6. So here answer is 6. So if you come here, you can see minus means 9, minus 10, 20, 15. So this is one of the path. If you combine all of this, you will get one answer. And if you get all of this, like if you let's say you are adding this, so 15, 20, 7, if you add all of them, you will get 42. So this is your answer, because this is the largest sum, or you can say maximum sum. If you add any other things, you will get less sum only. How? So let's say you if you are adding this and this, so let's say how much you will get. So this is minus 10, so you are adding 20 plus 15. Okay, 34, which is very much more less than compared to this. So from this, what you can understand, so as you are going in this way, you are getting less sum, but if you are going in this way, you are getting more sum. So the question is how to find this. So recursion can solve this problem. How recursion can solve this problem? So basically you can think of like, so let's say you have a node, so you have left node and you have right node, okay, so on, okay, so on. So first of all, if you consider this node, so let's say this is left, you need to find left max. For this node, you need to say you need to find R max. So at finally you can say, so left max plus right max plus that node value. So this is the thing that you need to say, and you need to maximize this, because see, so for a single node you can call recursively for this node, you can go after for this node and you can call recursively here, and here you can come and you can call recursively here. So in that fashion, you can call this left max and you can call that right max, and you can add with that node value also. I hope this makes some sense now. Now with that also, you can carry a variable called maxi, and you can compare all the stuff with that maxi. So let's say, so here we have the tree. Now what is maxi? So maxi is nothing but, first of all, so you need to see, so at first maxi is, we need to initialize with the minimum value. Minimum value we need to initialize this maxi. So after that, first we need to go across this. So after going across this, in the maxi we will update to 32. Okay, because as we are going in this path, so maxi will be updated to 32. So after that, we know that after this will call this side, this will call this side. Okay, so first of all, it will call this side, so which will be returning 0 over here, and here also nothing will be here, return 0. So 0 plus 9 will return from this side 9. Okay, here also you will call, so one call will go here, one call will go here, so will be returned 0, because nothing is there. So nothing is there, one call will be as returning 0, and finally it will return 15. Okay, and finally it will also return 7. So 15, here it is 15. So 15 plus 7 plus 20. So how much it is? So 15 plus 7 plus 20, which is 42. So basically you can see over here, so it is you are getting 9 here, you are getting 42 here. Finally you can add, so 9 minus 10 plus 42. So this is the final answer for this node. So for this node, up to now what we have calculated, so left max we have calculated, that is 9, right max we have calculated, that is 42 and 9, and at node value, which is minus 10, that also we are adding. If you did this also, you are going to get a less value only. Okay, so ultimately our final answer is 42, because you see you are subtracting from 42, so ultimately will yield a value which is less than 42 only. So our answer is 42, because while we are traversing only, we are keep storing the value of 42 and keeping that in max value, and we will update the max value which is now current 42. Okay, so in this fashion we are going to solve this value, solve this problem. So now let us go to the problem statement and let's solve that. So now I came here, now we need to code this up. So see clearly, I will be going to solve this in C++. So first of all, I will declare a maxi variable. So for the maximum value, first you initialize with the minimum value, so that after that you will get the store the maximum value, right? So you need to start with the minimum value. Okay, I started. So next we need to maximum sum path, sum down. Okay, I'm calling this function maximum sum down. So inside this maximum sum down, you will pass root and that maximum value. So after that passing that value, you can simply return maximum value. Okay, that's as simple as that. Now what I will do is I will come here and I will make a private. Inside that I will make some functions. As I will make a function. So the function is of return type int, and I will say, so this is the function that we are going to have, and inside that we are going to accept two arguments. So one is that of type tree node, okay, which is let's say we have we will call it as node, and the other value is maxi int. Let's say I will accept it as reference, pass by reference. Okay, up to here I hope there is no problem. Now, so first of all I need to calculate the left. Okay, here, okay, let's say max of, so 0. If you are getting negative sum from, let's say you are getting negative sum from here, you don't want that, so you can simply have the 0 over here. Then I will recursively call this as maximum sum down. Okay, maximum sum down. See, this function only I am calling, because as you know recursion, so yeah, call that with the help of the node left first. So as you are having node left, and you can simply pass maxi only. So this is the one thing, and next thing is you need to pass the right value. So if you want to get the right value, you can simply have the right one. So here you have the right and maxi, and finally you need to update the maxi. You can say max of, so maxi comma, so you already calculated the left value and right value, so you can simply add them up. So you can simply say left, you can simply say right, and finally you can simply so add that value also, because you will go for this node, you will get maximum value from here, you will get maximum from value here, and you need to this value also. So I will say node and I will say val, because you can see the val is declared over here, so that's why this is the syntax. And finally you can return. So this is the return is very important, because you are returning the maximum value. What maximum value? You are returning the maximum value of the left and the right. Okay, and with that you are adding the node value. Let's say you are not getting any maximum value here, but you are getting maximum value here. So for this you need to add something. So this value plus only this max value. Okay, that I am adding here. After adding this, you need to move this side and you need to calculate recursively. So that's why you need to get the positive value, because if you are getting negative value from this side, so don't consider this. Okay, so that's the main thing. So that's why we are writing base case also here. If that node that you are getting node is equals to null, let's say you are not getting any node, so you can simply say return 0. Because as you can see here, if you go there, if there is nothing, so you can simply return 0 for this. Okay, as you can see here, as you're going here, if there is nothing, it is null. Here also it is null, so that's the reason you are returning 0. So here you are getting 0, you are getting 0, so that's why you are able to add for this 0 plus 15, that you can able to return from here back. That's that way. Okay, then okay, this is it. This is not that much more complex. So if I run this, now you can see it's running fine. So you can see it's running fine. Now let us submit that. So you can see all the 96 test cases has been successfully passed. So I hope you like this video. So now let us discuss the time complexity once. So we have come to an end of this video. Now if you understand the time complexity, that's it. Okay, let's say you are having 3 nodes over here. Okay, first of all, for these 3 nodes, you are recursively going here, you are recursively going here, which is nothing but it's a pre-order kind of thing. Okay, it's a pre-order kind of thing, and you can also understand that from the code. This is pre-order kind of thing, and you are visiting every node once. So you can say like you are visiting every node once. So you can simply say the time complexity order of n. If you are having n nodes, the space complexity is order of n, which is the recursive stack space. So this is the time and space complexity. And why I am saying that like it is like a pre-order, because if you come to the code, so if you know the pre-order code, so first of all you will calculate the left and next you will calculate the right, and after that you will perform what is the operation that you want. So that is known as pre-order. So it's looking like pre-order or something like that.